In this video, we'll look at the shifts of sinusoidal functions. In particular, we're going to identify the phase shift, vertical shift, and the midline of a shifted sinusoidal function, as well as using all of the attributes that we've seen, the amplitude, period, phase shift, and vertical shift, to graph a sinusoidal function. We're now going to return to the most general form for our sinusoidal curve formulas, namely y equals a sine bx minus c plus d, or y equals a cosine bx minus c plus d. We've already seen that the values of a and b help determine the amplitude and the period of our curve, and so now we're going to turn our attention to the values of c and d to see how they impact both our function and the graph of the function. It turns out that both of these values will give us shifts of our graph. The c will give us will help determine our horizontal shift, and the d will help with the vertical shift. In order to really see how the value of c is useful for the horizontal shift, we need to look at that expression bx minus c and factor out a b. And when we do that, we're left with b times the quantity x minus c over b. So we've just factored out a b from both of those numbers. With c, that involves dividing by the number b. Now, what you might recall from algebra is that when we have a function and we subtract a constant from a variable, like we're doing here, that gives us a horizontal shift. And the value that's being subtracted is the value of that particular shift. And so here our horizontal shift is given by the value c over b, whatever number that happens to be in a particular formula. We also might remember that if we take a function like the a cosine bx minus c or the a sine bx minus c, and we add a constant to it, that this gives us a vertical shift. Again, by that same value. And so by looking at those two values, we're able to take our sinusoidal curve with our amplitude and period determined by a and b, and we can use c and d, and of course b for the horizontal shift, to find our shifts for our function. When we're talking about trig functions, the horizontal shift is often called a phase shift, but this is just a fancy name for a horizontal shift. And the phase shift here is given by the number c over b. In particular, if this number is positive, this will be a shift to the right. And if this number is negative, this will be a shift to the left. Now notice that the number c here in the formula is the number being subtracted. So that is a very important thing to observe, that c is the number being subtracted. And we'll see in an example shortly where we might have to be careful with that. So our phase shift is c over b. We also have a vertical shift, which is given by the number d. This is a little bit easier to determine. There's no arithmetic here. We just read the number d. And again, the direction of the shift will be indicated by whether d is positive or negative. So a positive value of d will tell us we want to shift up d units, and a negative value will tell us we want to shift down the appropriate number of units. And the last thing that is associated with this, along with the vertical shift, is the idea of the midline. We know for normal sine and cosine curves that the midline is y equal to 0. But if we do a vertical shift, the midline will shift by the same amount and will become the line y equals d. And so this is important when we go to graph a sinusoidal curve with a vertical shift. The midline will no longer be the x-axis, but rather the line y equal to d. In this example, we want to determine both the direction and the magnitude of the phase shift and the horizontal shift for this particular sinusoidal curve, given by y equals sine of x plus pi over 6 minus 2. In order to do this, we're going to compare this function with the general sinusoidal function, a sine bx minus c plus d. When we compare this, one thing that we should notice right away is that in our general formula, the c is the number being subtracted. And here in our given function, we're adding the number pi over 6. And so in order to make sure we use the correct value of c, what we're going to do is rewrite this function so that it has the negative sign in it. So this we can think of as sine, and instead of x plus pi over 6, we can think of that as x minus negative pi over 6 minus 2. Right? And so now, looking at this and comparing these formulas, maybe we'll line this up now over here. Looking at these formulas, we can see that our b value is going to be 1. Our c value is going to be negative pi over 6. And our d value will be negative 2. Because on the outside, the number being added is a negative 2. And this allows us to answer all of our questions that were being asked here. For the phase shift, for example, we know that the formula for this is c divided by b. And we have these values. C is negative pi over 6, and b is 1. So we have a phase shift of negative pi over 6. And if we wanted to describe this as direction and magnitude, this would be pi over 6 units. This will be the amount that we shift. And because it is a negative value, we're going to shift this to the left. So our magnitude of our phase shift is pi over 6, and it goes to the left. Again, because the phase shift is negative. Again, I'll point out that it's important to have rewritten the original function as x minus negative pi over 6 in order to remember that the value of c in this particular function would be negative. For the vertical shift, we know that it is the value of d, which is negative 2. And so this would be a vertical shift of 2 units downward. It's downward because the value of d there, negative 2, is a negative number. And so this graph has a horizontal shift of pi over 6 units to the left and a 2-unit shift downward. In this example, we'd like to sketch one period of the graph of the function y equals 2 cosine of 3x plus pi over 2 plus 1. In order to do this, we need to find all of the various attributes of the graph that we've discussed, namely the amplitude, period, phase shift, and vertical shift. And we can do that with all of the values given in the function. Here we have an a value equal to 2, a b value equal to 3, a c value of negative pi over 2. We'll make that very clear that that is negative. Again, that is because the c is the value being subtracted from the formula, and therefore we really should think of that as 3x minus negative pi over 2 to see that we get a c value of negative pi over 2, and a d value equal to 1, since we're adding the number 1 to this. And from this, we can get all of the values that all of the attributes of our function that we need. Our amplitude is going to be the absolute value of a, or absolute value of 2, which is 2. So our graph will have a height of 2 units from the midline. Our period is 2 pi divided by b. B here is 3, so we get 2 pi over 3. And that doesn't simplify in any way, so our period is simply 2 pi over 3. Our phase shift will be c divided by b, and so we have negative pi over 2 divided by 3, and that simplifies to negative pi over 6. like the last example, this is a shift to the left because it is a negative value. So we'll shift our starting point of our graph over pi over 6 units to the left. The vertical shift is going to be 1, and since 1 is positive, it's 1 unit upward. And the last attribute that is important is our midline, and we know that the midline is always the x-axis shifted with the same vertical shift, and therefore, since we're shifting up 1, our midline will be the equation y equals 1. And now to actually sketch one period of this graph, we're just going to put all of these, or sketch a graph that satisfies all of these values here. Right. So the first thing that we can do is identify the midline, which is y equal 1, and I'll do that as a dotted line. So this will be the midline for our function. We know that it has an amplitude of 2, which means the graph will jump 2 units above this line, so that will go up to y equal 3, and it will also jump to 2 units below this line, which will be negative 1. So our graph of this function will go between a minimum value of negative 1 and a maximum value of 3. Right, we also have the phase shift here, which is a pi over 6 shift to the left. And so that means our graph is going to start over here at negative pi over 6. We have the value of a cosine graph here and the positive value in front, which means at negative pi over 6, our function is going to start at its at its maximum value, which in this case is 3. So I know that the starting point of our period that we're going to graph is at the point negative pi over 6, comma 3, which I plotted here in red. Now, before we can graph the rest of this, we do need to know sort of the ending point for our graph. Recall that we know the period is 2 pi over 3. And so starting at negative pi over 6, we need this distance here to be 2 pi over 3. And so in order to figure out the ending point over here, the value on the x-axis where this period will end, what we need to do is just simply take our starting point, negative pi over 6, and add 2 pi over 3 to that and see what we end up with. And that will be the x-coordinate for our ending point. And so this will be negative pi over 6 plus 4 pi over 6 by finding a common denominator. When we add those together, we get 3 pi over 6, which is pi over 2. And so our ending point for our graph will be the point pi over 2. And so we know the graph also, this period of cosine will also hit its maximum value at the ending point of the period. So we end up something over here at the point pi over 2, comma 3. Right? And now the rest of the graph looks exactly like a period of cosine with the appropriate values that we have plotted. So we start here at a max value. We know that it comes down, crosses our midline of 1, hits our min value of negative 1, and then returns back up to its max value. So our graph will look something roughly like this. Notice looking at this that we see that we have an amplitude of 2, we have a period of 2 pi over 3, we have a phase shift of pi over 6 units to the left, we have a vertical shift up 1, which gives us a midline of y equals 1. So all of the attributes on the previous slide appear here in this graph. If you'd like to practice with a similar problem, try to sketch one period of the graph y equals 4 sine 2x minus 2 pi over 3 minus 2. First, like the example, find all of the various attributes, the amplitude, period, phase shift, vertical shift, and midline, and then use those values to sketch the graph. All of those attributes and the graph will appear in just a few seconds. Notice here that the value of c is a positive number, 2 pi over 3, because that's being subtracted in the formula. And the value of d is negative 2, because negative 2 is the number being added. So here we started the graph with the midline at negative 2. the graph will go up 4 units to +2 and down 4 units to -6. We have a phase shift of pi over 3, and that is to the right. And so our graph will start at the x value of pi over 3. And since our graph has a period of pi, we're going to add pi to pi over 3 to get 4 pi over 3, which will be our ending point. And then since this is the sine graph, we know the period will start and end at the midline, which is -2, and then first go up to its max value and then to its min value. And we obtain the graph shown here.